This is a magnetron. When we remove its metal coating, we see that its main components are an antenna from which the microwaves are ejected, two magnets, and an anode and cathode. In this video, we're going to be focusing on the magnets and the anode and cathode. The cathode is a ring-shaped grooved piece of metal. The anode is a cylindrical piece of metal which is attached to a voltage source. The anode accumulates electrons until the repulsion between them is so great that they push off towards the cathode. To move on to the magnet component, the poles of both magnets and the magnetron are aligned. This means that the magnetic field of each point in the same direction and overlap. The space between the two magnets, where the anode and cathode are, experiences a strong and constant magnetic field. This is all important because magnetic fields exert a force on electrons called a Lorentz force. The force depends on the magnitude of the charge, its velocity, and the magnetic field, and the direction of the force can be found with the right-hand rule. This online circuit will help demonstrate the Lorentz force. This circuit consists of only a battery. The wire passes through the north and south end of a magnet, and this is where we want to focus. Notice that the wire is stationary when the circuit is disconnected, but is pushed when the circuit is closed. This is because when electrons move through the wire between the magnets, they experience the Lorentz force and get pushed, and they push the wire.
We use the Lorentz force on a small sample of electrons and see that this force is perpendicular to the electron direction motion. This causes the electrons to spiral counterclockwise. The actual electron stream ejected from the anode strike the cathode cavity edges. These edges gain a negative charge. The stream strikes the edge to its left at the next instant, leaving the earlier edge positively charged. So we see how at small time intervals, there is an alternative charge at the cavity edges. There is current flow from the positive potential to the negative potential. Due to the design of the cavity, the stream strikes it at resonant frequency. The potential difference does work on this charge, creating energy of frequency in the microwave range. The antenna directs the microwave into the oven, which reflects off the walls and enters into the food. This excites the water molecules in the food and heats the food up. This is how a microwave oven operates.